In this video, we'll see how to create functions with multiple inputs or multiple outputs. One thing I'm going to do is, in this script where I was taking notes, I'm going to highlight this whole piece where I've got the sample function. This was the definition, and I'm going to comment. So I'm going to go up here to where it says comment and comment the whole thing out, because I'm going to define a different function, or I'm going to call functions from this script, and I want to be able to not run into a problem with MATLAB. So this will be my notes script. Right now there's no commands in it. So I'll tell you what I'm going to do. Multiple inputs. Let's say create a script file, a separate file with the following code. And I'll copy and paste it back in here once we've created it. That way it'll be in my notes file, but I need it in a separate file in order for MATLAB to run it. Because remember, the name of the file has to match the name of the function. So if you change the name of your function, you've also got to change the name of your file to match. So I want to do, remember we start with the word function, I'll call the output output, equal sign, we'll give this a name, let's call it just G for the moment until we figure out what it's going to do. G is a good function name for now. What should this function do? This function multiplies X and Y together. So notice I've got two inputs, I'm going to multiply them together. Let's change the name of this to myMult, now that I know what it's doing. This function multiplies the inputs together. Okay, inputs, sizes must agree. And I say that because MATLAB is going to give us an error if the sizes don't agree. And I don't want to mess with errors and stuff like that. So I'll just say, let's say they have to agree. And let's call it A. A equals X dot star Y. Dot star, remember, in case these are matrices, that will create element by element multiplication instead of matrix multiplication, which is what we want. So we have an intermediate calculation step. This could be useful in larger problems, larger functions. Functions, I will say. Okay, that's fine. And then once we do all the intermediate calculations, we say, what is the output going to be? In this case, just A. By the way, notice that I'm suppressing the output here. Let's see what happens if I don't, actually. Let's leave that and say, well, the user asked for this. They must want to know what the result is, so let's tell it to them. Let's see what happens. And then don't forget the word end. That tells MATLAB that we have reached the end, and you can now send the output back to whoever called this function. So I need to save it. So I'm going to save it as myMult. And now it's in my list as a function file, so I can see that. I can use it from the command window and say 1 and 1. How about 2 and 10? And I get 20. Wait a minute. Look at what I get. I get output equals 20 and answer equals 20. So I get it twice. And that's because this call, where I actually called the function, does not have a semicolon. So it's already not suppressing the output of the function call. If I don't have a semicolon here, I'm going to get it twice. Once where I've declared output to be equal to this result, and once where I haven't declared anything, it's just the answer in MATLAB is equal to that result. So go ahead and add that semicolon, suppress output here. We don't want this line reporting to the command window every time this function is called. Instead, let the user decide when they call it whether or not to report the output to the command window or wherever. Okay, so we've called this function from within the command window. Great. Notice that X and Y and output, and A for that matter, are not in our workspace. We can't access them. Let's go back to the script. Oops, I said I would copy and paste it. Let's do that in a minute though, because I want to actually call this function from the script. we can do that, and I want to make sure we know we can do that. So my number 1 is going to be, let's say 1 to 5. So let's do it with a one-dimensional array. And number set 2 will be 5 to 9. So I'm just using integers here. And then I'm going to call the function that I just made by saying, let's call it result. And that will be the result of my molt, which is the name of the function, and in parentheses, number 1, number 2. By the way, look at this little pop-up we get. It's saying, hey, here's how many inputs this function thinks it's going to get. So that's kind of nice. And now let's go ahead and not suppress this output. And so I'll say no semicolon here because I want to see the result at some point. Now I'm going to run this section, and this is how I can get away with having other things defined elsewhere. I'm just running this section, so the only commands that are going to execute are the ones here. I think I'm going to need to, nope, you don't need to save it if you're doing just a run a section. So I have num1 because that was part of the script that was executed right here in this main workspace. I have num2, 5 through 9, and then I get my result, which is 1 times 5, 2 times 6, 3 times 7, and so on. And I have those in the command window here because I did not have a semicolon. So as long as we have the same name on our function as is the file name, we can use that from any other script or any other function actually, as long as we're in the same working directory. So in my current folder, my molt.m exists. That's why I can use it. Great. What if I'm sending my file to somebody else, like my instructor, who doesn't have all of these function files that I've built? That will be in our next video. I'll see you then.